Welcome to Science for Sleep, where wonder and calm meet. Each night we drift through galaxies, oceans, and mysteries of the natural world, not to startle, but to soothe, where light never reaches, the darkest places in the known universe. In space, darkness isn't the absence of light. It's the story of light's exhaustion, the slow unraveling of its journey until it can no longer be seen. Every beam that leaves a star travels outward forever. But along the way, it weakens, stretches, and fades. The universe is vast enough to wear light down to silence. And in that silence, there is a kind of beauty. Not in what we see, but in what remains unseen. Astronomers measure darkness not as blackness, but as density, how few photons reach a given point in space. In the most remote regions, a cubic meter might contain only a handful of light particles. That handful, spread thinly across eternity, is what gives space its quiet hue. It's never perfectly black. It's just the lowest whisper of blue. To understand darkness, one must first understand how light behaves. Photons, those tiny carriers of energy, don't fade on their own. They stretch. As they move through an expanding universe, their wavelengths grow longer, sliding down the spectrum. What began as visible light becomes infrared, then microwave, then radio. Light never disappears. It merely slows beyond the limits of our eyes. Darkness, then, is light's retirement, the moment when brightness chooses to rest. In the earliest age of the cosmos, there was no darkness at all. The universe glowed with a hot, uniform radiance, brighter than 1,000 suns. As it cooled, the glow thinned, and atoms began to form. Hydrogen, helium, traces of lithium. These simple elements swallowed the light around them, and shadows were born. The first darkness wasn't an absence. It was creation's pause, a breath between bursts of light. Today, that ancient glow still exists as the cosmic microwave background, a faint murmur of radiation left over from the Big Bang. Astronomers have mapped it in soft blue and orange shades, showing minute variations that seeded galaxies. But to the human eye, it's invisible. The universe's first light is now its faintest. Darkness is simply that light, stretched and tired after 13.8 billion years of travel. When we peer into space, we're not looking at blackness. We're looking at distance. Light takes time to reach us. 1 second from the moon, 8 minutes from the sun, 4 years from Alpha Centauri. But beyond that, time itself slows the light. The farther we look, the older what we see. Darkness becomes a kind of time machine. Every shadow is a record of light's delay. There are regions, however, where light doesn't merely fade, it's trapped. These are the dark nebulae, clouds so thick with dust and gas that starlight cannot pass through. To the naked eye, they appear as voids, empty holes punched through the Milky Way. But through infrared telescopes, they bloom with hidden detail. Nurseries where new stars are quietly forming behind curtains of dust. In the Orion molecular cloud, for instance, entire clusters of suns gestate unseen, their glow muffled until they burst through the darkness millions of years later. These dark patches are not emptiness. They are wombs of light. Scientists often say that darkness is structure. Without it, stars would never rest long enough to form. The cold allows matter to gather. Gravity works best where heat is low, and heat can only fade where light retreats. Darkness, paradoxically, is the architect of brightness. The human eye is poorly equipped for cosmic darkness. Even under perfect conditions, we can detect only a few thousand stars. Beyond that, our vision fails. Though the sky remains filled with light we cannot see. Ultraviolet from hot stars, infrared from dying ones, radio from hydrogen atoms, whispering across billions of years. Our instruments extend those senses, revealing that what looks empty is often the most crowded of all. The universe hides its abundance inside its shadows. When the Hubble Deep Field was first released, that single image taken from a tiny blank spot in the sky, astronomers discovered over 10,000 galaxies in an area smaller than a grain of sand held at arm's length. What had appeared black was actually filled with ancient light. The photograph taught us something profound. Darkness is never total. It's a pause between brightnesses, a waiting room for light. There are also places where darkness becomes something else entirely, an active force rather than a passive absence. In the centers of galaxies lie supermassive black holes, objects so dense that even light cannot escape their gravity. Their event horizons mark the boundaries between visibility and forever. Here, photons curve endlessly, trapped in circular orbits before vanishing into silence. These are the ultimate shadows, the points where the universe stops reflecting and begins remembering. Yet even there, not everything is lost. Around black holes swirl disks of matter so hot they emit X-rays, ultraviolet flares, and magnetic storms. The darkness of the whole becomes the source of the brightest light in existence. As if the cosmos were saying, even the void can shine, if only for a moment before surrender. When we map such regions, we do it indirectly. Light bends around massive objects, a phenomenon called gravitational lensing. It allows astronomers to see galaxies hidden behind other galaxies, their light warped and magnified by invisible mass. In these distortions, we glimpse both light and darkness at once, illumination guided by shadow. The universe, it seems, prefers balance over clarity. But there's a darker dark still, something even black holes can't define. We call it the cosmic voids. These are vast regions spanning hundreds of millions of light years, where almost no galaxies exist. They are the great gaps in the cosmic web, the spaces between filaments of matter. Within them, the density of atoms is so low that a cubic kilometer might contain fewer particles than a breath of air. Nothing glows there. Nothing reflects. The voids are the quietest places known to physics. Absolute calm at cosmic scale. In one of these voids, called the Boots Void, astronomers found only a few dozen galaxies scattered across a sphere 330 million light-years wide. The rest is simply dark, not malevolent, not empty, just still. The photons that cross this region travel for eons without meeting resistance. In that endless drift, their light stretches until it becomes background, an eternal sigh of radiation, the music of remoteness. To travel there would not be to see blackness, but to experience absence. Your eyes would find nothing to fix on, your instruments nothing to measure. You'd float in a sea of near-perfect silence, surrounded by the faint echo of the Big Bang, a background hum at 2.7 Kelvin. The feeling would not be fear, but humility. Darkness here is not a threat, it's a truth. And yet, even in the darkest void, light exists. Every now and then, a wandering photon passes through, released from a quasar billions of years away. It streaks silently through the emptiness, unscattered, eternal. That single photon might one day strike the mirror of a telescope, completing its journey. One tiny glint in a sea of black, a reminder that nothing truly disappears. In laboratories on Earth, physicists create artificial darkness to study it. They use vacuum chambers and laser traps to remove every particle of light, cooling atoms until they nearly stop moving. What they find is not emptiness, but structure, quantum fluctuations that dance even in nothingness. The vacuum is never silent. It hums with virtual particles appearing and vanishing faster than time can count. The universe cannot stop creating, even when it tries. This realization changed everything. Darkness, once thought of as nothing, is now known to be full of energy, the zero-point field that gives rise to everything. Even between the stars, even between the atoms, there is always something. A flicker, a possibility, a breath. As you imagine this vast canvas of soft dark, remember that the same emptiness exists within you. Between every electron and every atom of your body lies more nothing than substance. You are mostly space, held together by the same fields that shape galaxies. The darkness of space is not distant. It is intimate. It lives within the matter of your being. And so, the meaning of darkness is not absence. It's unity. It's the quiet connection between all things, the medium through which stars speak, the silence that lets their music be heard. In the beginning, there was light. But first, there was the potential for it, the darkness that waited patiently for the spark. Between the stars lies a silence older than any galaxy, a stillness so vast that it defies imagination. Astronomers call it the interstellar medium, yet it feels more like an ocean made of near nothingness. Each atom drifts for centuries before meeting another. Each photon passes through distances so wide that time itself seems to stretch. It is the space between stories, the quiet intervals that make the symphony of creation possible. When we look up at the night sky, the stars seem close, scattered like grains of salt across black velvet. But the distances between them are immense. If the sun were a sphere the size of a ping-pong ball, the nearest star, Proxima Centauri, would be another ping-pong ball 400 kilometers away. The space between them would be almost perfectly empty. Yet even that emptiness hums with invisible life. The interstellar medium is made mostly of hydrogen, the simplest element in existence. A cubic meter of this space might contain a single atom, fewer than in a puff of breath. But spread across billions of cubic light years, those atoms add up. They form the raw material of stars, the quiet dust that will one day ignite. It is in these gaps that the next generation of light sleeps, waiting for gravity's call. Instruments like the Voyager spacecraft and the Interstellar Boundary Explorer, IBX, have mapped the edge of our sun's influence, the point where the solar wind gives way to the true interstellar flow. Beyond that invisible frontier lies the unfiltered environment of the galaxy, the true night. The probes describe it not in images, but in numbers: magnetic field strength, plasma density, cosmic ray counts. The results show that the void isn't a void at all. It's textured, dynamic, alive in its own slow way. Imagine floating there. No light, no sound, no direction. you would be surrounded by a temperature of about 2.7 Kelvin, just above absolute zero. That faint warmth isn't from nearby stars, but from the afterglow of the Big Bang. The same cosmic microwave background that fills all of space. Even in darkness, the universe remembers its own birth. Astronomers once believed that nothing moved in such stillness. Then they discovered interstellar clouds, vast concentrations of hydrogen and dust drifting through the galaxy like invisible continents. Some are dense enough to block starlight completely, others so thin that their presence can only be detected through radio waves. These clouds shift and merge over millions of years, sculpted by supernova explosions and magnetic fields. From their slow collisions, new stars emerge. The space between stars, it turns out, is where stars themselves are born. The Orion Eridanus superbubble, for instance, is a vast cavity carved by ancient stellar winds. Its edges glow faintly in ultraviolet, a delicate rim of light marking where expanding gases meet the cold. Within that hollow region, turbulence moves like a slow breath. Over eons, gravity will reclaim the fragments, condensing them again into light. The universe breathes. Exhale, darkness. Inhale, brightness. When we speak of cosmic dust, we don't mean soot or smoke. These are grains smaller than pollen, composed of carbon, silicon, and iron. They drift for millions of years, collecting icy mantles of water and ammonia, serving as seeds for planets and moons. Every world that exists began as dust between stars. And every atom in your body once floated there too, forged in a supernova, cooled in the void, gathered by gravity into the matter that became you. You are, quite literally, made of the space between stars. The interstellar medium is not uniform. Some regions glow faintly with ionized gas, pinks and blues invisible to the human eye, but radiant in infrared. Others are cold and dark, their temperatures just a few degrees above absolute zero. Instruments like the James Webb Space Telescope peer into these shadows, translating wavelengths into color. What emerges are images of delicate filaments, waves, and knots. Cosmic lace woven from nothing but hydrogen. Each line marks a path of density, a place where light will one day return. If you could listen to this environment, it would hum. Plasma waves travel through it at the speed of sound in air, though no human ear could detect them. They resonate at frequencies far below hearing, gentle oscillations caused by the motion of charged particles. Voyager's instruments once picked up such a hum, a low, continuous tone that lasted for months. It was the sound of the galaxy's breathing. In that hum lies a strange comfort. It means the void is not empty. It participates. Every atom, every field line, every photon that crosses it adds to the chorus. The darkness between stars is less a void than a stage where energy and matter exchange whispers across eternity. Scientists measure these whispers with radio telescopes tuned to 21 centimeters, the wavelength emitted when a hydrogen atom flips its internal spin. This single spectral line has mapped the entire galaxy, revealing spiral arms, voids, and clouds invisible to optical telescopes. Through it, astronomers can see the structure of the Milky Way from within. The map looks like a slow river of brightness winding through shadow, a reminder that even unseen matter leaves a trace of its being. When light from distant stars passes through these regions, it doesn't travel unchanged. The dust scatters blue wavelengths more than red, giving starlight a warmer hue. This is why stars near the galactic plane often appear orange or crimson. They have traveled through long corridors of soft obscurity. Every color we see in the night sky has been shaped by the darkness it crossed. The void is the artist, the starlight its canvas. In the most remote interstellar expanses, there are also molecules, carbon chains, alcohols, and even simple amino acids drifting freely in gas form. Observations from the ALMA array in Chile have identified over 200 organic compounds in these dark regions. They are the precursors of life, assembled not on planets, but in the deep, cold emptiness between them. Life, it seems, begins in silence. When supernovae explode, they send shockwaves across light years, compressing these clouds and seeding them with heavier elements: gold, uranium, phosphorus. Each wave adds new ingredients to the recipe. When the shock passes, the darkness reforms, infused with potential. This is the cycle of creation. Light gives way to shadow, and shadow gathers itself into new light. If you could stand still long enough, you would see stars drifting slowly through this field, their motion imperceptible to the eye, but precise to the mind. Each star leaves a wake, a trail of ionized gas and dust stirred by its magnetic field. The wakes overlap, weaving invisible filaments that connect distant systems. The galaxy is one vast web, and the spaces between are its threads. Darkness has shape. It folds around gravity wells, flows along fields, and forms bridges between galaxies. Even emptiness obeys geometry. The more we study it, the more we realize it isn't nothing. It's the quiet scaffolding of everything. And so, the space between stars is not isolation, but continuity. Every atom that leaves one star will one day belong to another. Every photon that travels through the dark adds its energy to the collective glow of the universe. There are no true gaps, only gradients of light. What we call empty is simply full of potential, not yet visible. If your eyes feel heavy, let them rest. Picture that vast ocean of silence stretching in all directions. Feel yourself drifting through it, weightless, surrounded by nothing but stillness. Between each of your breaths lies a smaller version of that same space, a pause, a distance, a calm. The universe mirrors your breathing, and you mirror its. You are not separate from the space between stars. You are its echo, its continuation, its dream. In the quiet fabric of the universe, there exist places where even light surrenders, where the known laws of time and matter bend until they blur. These are the black holes, the ultimate shadows, born not from darkness itself, but from the collapse of light. To understand them is to accept paradox. A black hole is invisible, yet it defines the most luminous regions of space. Around it, light curves and twists, forming glowing rings, accretion disks, that shine brighter than entire galaxies. Within it, all that brightness ends in silence. At the heart of most galaxies, including our own Milky Way, lies one of these gravitational wells. Ours is called Sagittarius A, 4 million times the mass of the Sun, hidden behind clouds of interstellar dust. It's quiet now, dormant, but its presence shapes the motion of every star within thousands of light years. We orbit its invisible pull, bound to a center we cannot see. The physics of black holes begins with a simple truth. When a massive star runs out of fuel, it collapses. Gravity, no longer balanced by pressure from fusion, crushes the core inward. For the heaviest stars, this collapse has no end. It continues until the density becomes infinite, and space-time itself curves so sharply that escape becomes impossible. That boundary is called the event horizon. Cross it, and every path forward leads inward. Even light has no path out. To an outside observer, though, something strange happens. As matter falls toward the event horizon, time appears to slow. Photons climbing away from that gravity lose energy, their wavelengths stretching until they fade to red, then to black. From our perspective, nothing ever truly crosses the horizon. It only fades from view, its image frozen at the edge forever. The black hole swallows time as much as it swallows light. The first photographic evidence of such a region came in 2019, when the Event Horizon Telescope, a network of observatories around the world, captured the silhouette of a black hole in the galaxy M87. What we saw was not the hole itself, but its shadow, outlined by glowing plasma orbiting at nearly the speed of light. The image, a golden ring around a dark center, confirmed Einstein's predictions in stunning clarity. The universe had drawn its own eye. Since then, astronomers have continued to refine that image, using machine learning to extract detail from radio waves distorted by distance and turbulence. Each improvement reveals that the ring is not perfectly circular. It ripples, flickers, changes with time. Even in silence, black holes move. Some of the most fascinating black holes are not massive giants, but their smaller cousins, the remnants of single stars scattered across the galaxy. When two of these orbit each other, they create gravitational waves, ripples in space-time detected by observatories like LIGO and Virgo. These waves pass through everything, stretching and compressing space itself. Each one is a message from a collision that happened millions of years ago. When they reach Earth, they are smaller than the width of a proton, yet they carry the energy of suns. The sound of a black hole merger, translated from those waves into audible frequency, is a short, rising tone. A chirp that begins low and ends high, then vanishes. In that brief moment, two stars cease to exist, replaced by a single, larger hole, its spin encoding their final dance. To listen to it is to hear gravity itself sing. Inside a black hole, our equations falter. The known laws of physics can describe everything up to the event horizon. But beyond it, we have only theory. A singularity where density becomes infinite and time ceases to flow. Quantum mechanics and general relativity cannot yet be reconciled there. It is, quite literally, where knowledge ends. Yet physicists suspect that information, the blueprint of everything that falls in, might not be lost. Stephen Hawking proposed that black holes emit faint radiation as particles escape through quantum fluctuations near the horizon. This Hawking radiation is unimaginably weak, but means that black holes could slowly evaporate over trillions of years. Even the darkest entities are not eternal. They fade, like everything else. In that decay lies the universe's quiet mercy. Nothing lasts forever, not even the infinite. Every shadow will someday give back its light. Astronomers observing stellar mass black holes in binary systems often see bursts of X-rays as matter spirals inward, heating to millions of degrees. These outbursts flicker unpredictably, a cosmic heartbeat of accretion and release. The black hole itself never emits, but its surroundings tell its story. Light traces its presence. Silence defines its shape. If one could drift near such a region, safely distant, just beyond the point of no return, the view would defy sense. Behind you, the stars of the universe would bend around the hole, their light warped into a halo. Ahead, nothing but darkness, not as emptiness, but as curvature, the bending of all directions into one. Gravity becomes geometry, time becomes surface. There is a poetic symmetry here. Black holes, once feared as destroyers, may also be creators. Some theories suggest that the singularities within them might seed new universes, that every collapse could be a beginning elsewhere. The cosmos may recycle itself endlessly, light collapsing into darkness birthing new light. If your mind wanders as you imagine this, let it drift. Picture the slow spiral of gas around an unseen center, glowing brighter as it approaches its end, then fading into quiet. That brightness, those last photons, travel across millions of light years, perhaps landing in your eyes tonight. Every star that dies gives a little of itself to our gaze. And somewhere, beyond the reach of any telescope, billions of these shadows turn in the deep, not as monsters, but as reminders. The universe is patient. It holds both endings and beginnings in the same silence. Light, by its nature, wants to move. It travels outward, endlessly, across every vacuum, through every obstacle that will let it pass. But there are places where even light grows weary, where space stretches it thin or gravity draws it inward. The quiet collapse of light is not sudden. It's a slow surrender. Every photon that leaves a star carries a bit of its history. Some travel freely, others are bent, absorbed, or delayed. Over billions of years, those photons lose their sharpness, their colors shifting toward red as the universe expands. This cosmological redshift is the gentle fading of energy, a universal dusk spreading across creation. Astronomers can read this fading like a clock. The farther a galaxy, the redder its light. Each increment marks another step in time, another measure of expansion. When we look at galaxies at the edge of the observable universe, we see them not as they are, but as they were when light first escaped them. Ancient, ghostly, long gone by now. Their glow has traveled billions of years just to reach us, only to be caught for a moment before fading into the background hum. In a sense, all visible light is already collapsing, not into black holes, but into invisibility. Each photon stretched until its energy blends with the cosmic microwave background. Over time, even the brightest stars will dim, their radiation joining the universal twilight. Astronomers call this distant era the degenerate age, when all starlight will have faded and only the faint warmth of dark matter and black hole evaporation remains. The physics of this fading is gentle but final. The universe expands faster than light can cross it, meaning that some regions will eventually drift beyond visibility forever. We will no longer see them, not because they've vanished, but because their light can no longer reach us. The cosmos is not closing. It is opening too quickly for its own reflection to keep up. Even in this grand dissolution, beauty persists. Infrared telescopes like JWST have captured the faintest light from the earliest galaxies. Their photons stretch nearly 1,000 times from their original color. These tiny specks on a dark field are the oldest surviving light in existence. Messages from a time when stars were first learning to shine. To look at them is to glimpse the first morning of the universe, softened by distance into an endless night. In this way, the collapse of light is not destruction, but transformation. Every beam becomes part of the background, part of the invisible warmth that fills all of space. The universe keeps its light. It just spreads it so thin we can no longer see it. Darkness, again, is not absence. It's the whisper of light too tired to shine. Far from every star, where starlight thins to nothing and the warmth of suns no longer reaches, lie the coldest places in existence. These are the regions where motion slows, where atoms barely stir, and where the universe reveals its quietest design. In astrophysics, cold means energy that is nearly left. The temperature of a cloud or a void is not felt as frost, but measured as the trembling of its molecules. The slower they move, the lower the heat. In interstellar space, between galaxies, that trembling almost stops. Here, the thermometer would read only a few degrees above absolute zero, the point where matter ceases to move at all. Among the most astonishing of these realms is the Boomerang Nebula, a faint bow-shaped cloud 5,000 light-years away in the constellation Centaurus. Astronomers call it the coldest known natural object in the universe. Its temperature is just 1 degree Kelvin, colder even than the background radiation left by the Big Bang. The nebula's chill comes from a dying star at its heart, expelling its outer layers so quickly that the gas expands and cools faster than the cosmos can warm it. In that expanding breath, the star has created a pocket of near-perfect stillness, a cosmic refrigerator drifting through the galaxy. Images from the Atacama Large Millimeter Array show the boomerang's structure glowing faintly in microwave light, its twin lobes curving outward like frozen wings. Inside them, gas moves at speeds of nearly 160 kilometers per second. Yet the energy is so thin that nothing burns. The nebula glows not because it is hot, but because the instruments translate invisible radio waves into color. To the human eye, it would appear as nothing at all, just black on black, the shape of cold carved into emptiness. Elsewhere in the cosmos, other regions rival that silence. In the Perseus cluster, immense clouds of gas surround a central black hole, whose jets carve cavities through the medium. These cavities, hundreds of thousands of light-years wide, cool to only a few Kelvin. Sound waves ripple through them, slow undulations that take millions of years to rise and fall. If they were audible, they would form the deepest note ever produced, a B-flat 57 octaves below middle C. It is a literal hum of cold, a vibration so long it becomes part of the background itself. On smaller scales, cold rules the birthplaces of stars. Dark molecular clouds, opaque even to infrared light, collapse under their own gravity until pockets within them grow dense enough to ignite. Before that ignition, their interiors hover around 10 Kelvin. Inside, molecules of carbon monoxide and ammonia drift lazily, bonding and breaking apart in the slow chemistry of darkness. It is in this near-frozen soup that planets begin to take shape. Every world, even warm ones like ours, begins as dust in the cold. Closer to home, spacecraft have measured the temperature of the Kuiper Belt, the ring of icy bodies beyond Neptune. There, sunlight is 1,000 times weaker than on Earth, and surfaces remain at about 40 Kelvin, cold enough for nitrogen to freeze solid. Objects like Pluto and Eris glitter faintly in reflected starlight, their frozen plains sculpted by heat that never truly arrives. To walk there, if one could, would be to move through shadow made of crystal. Beyond even that lies the Oort cloud, a hypothetical sphere of comets extending perhaps 2 light-years from the Sun. Its temperature matches the cosmic microwave background itself, 2.7 Kelvin. Here, the Sun is just another bright star among many, its warmth indistinguishable from the rest. Comets sleep in this deep freeze for billions of years until a passing star or gravitational wave disturbs them, sending them inward toward light and heat once more. Their brief brilliance near the Sun is a memory of the cold they left behind. Scientists recreate similar temperatures in laboratories using magnetic traps and laser cooling. Atoms slowed in these experiments reach billionths of a Kelvin, forming a Bose-Einstein condensate, a state of matter where particles overlap into one quantum wave. It is as if matter itself forgets individuality and becomes a single thought. These earthly experiments mirror the cosmos. Even in controlled rooms, we summon the quiet that fills the stars. Cold is not the enemy of life, it is its preserver. In the icy crusts of moons like Europa and Enceladus, warmth from tidal forces keeps oceans liquid beneath kilometers of frozen shell. At the surface, the temperature is below 100 Kelvin, yet jets of water erupt through fissures, carrying organic molecules into space. NASA's instruments have tasted these plumes and found evidence of salts, hydrogen, and carbon compounds. The alphabet of biology whispered from beneath the ice. The cold hides, but it also protects. If life exists there, it sleeps safely beneath the frost. Astronomers studying interstellar ices find complex organics embedded in grains of dust. Methanol, formaldehyde, even precursors to amino acids. Ultraviolet light and cosmic rays trigger chemistry, even at these frigid temperatures, slowly stitching simple molecules into elaborate ones. The process may take millions of years, yet time is abundant in the dark. When these grains fall into new solar systems, they carry with them the frozen memory of creation. Everywhere we look, cold defines the edges. The universe began in heat, but has spent almost all its life cooling. As it expands, energy spreads thinner. Radiation loses color. In the far future, when the last stars fade, the cosmos will settle toward a universal temperature just above absolute zero. Physicists call this the heat death. Not a violent ending, but a smooth dimming into perfect equilibrium. Motion will cease. Light will redshift beyond perception. Even then, there will remain a trace warmth, the faint whisper of everything that once was. When we describe these cold places, we also describe serenity. Nothing rushes in the Boomerang Nebula. Nothing burns in the Oort cloud. The atoms there move only because quantum law forbids them to be entirely still. In that nearly frozen vibration lies the final heartbeat of the universe. If your breathing has slowed while imagining this, let it. Feel the air cool slightly as you inhale, warm as you exhale. That small difference mirrors the same exchange that drives stars and nebula. Heat moves toward cold. Energy seeks balance. In the cosmos and within you, the same rule guides everything. Stillness is not emptiness. It is completion. Now drift, weightless, through that completion. Imagine the Boomerang Nebula expanding endlessly, its wings of gas stretching into blackness. Imagine comets slumbering in the Oort cloud, frozen tails curled inward like commas at the end of a sentence. Imagine the photons of the Big Bang stretching wider and cooler until they too rest. This is not the end of light. It is light at peace. There is a kind of light that does not dazzle, that moves not to be seen, but simply to continue. It is the oldest light in existence, the cosmic microwave background, the afterglow of the Big Bang. Discovered in 1965 by Arno Penzias and Robert Wilson, this radiation fills every direction equally, a soft haze of microwaves that has been traveling for nearly 14 billion years. To modern instruments, it appears as a temperature of 2.725 Kelvin, with slight ripples, variations only 1 part in 100,000. Those ripples are fossils of the first sound waves in the universe, the vibrations of matter and energy before there were stars. In them lies the blueprint for every galaxy that would ever form. When you look into a clear night sky, your eyes cannot see that ancient glow, but it touches you nonetheless. Every square centimeter of your skin receives about 400 photons from it each second. They pass through you unnoticed, gentle as breath. The forgotten light is everywhere, always arriving, always moving on. Satellites like COBE, WMAP, and Planck have mapped this background in exquisite detail. The maps look like soft clouds of blue and orange, each hue representing a tiny difference in temperature. From these patterns, scientists infer the universe's age, composition, and shape. They reveal that space is flat on the largest scales, and that most of the cosmos is made not of atoms, but of unseen energy and matter. All this knowledge comes from light so faint that it cannot cast a shadow. As the universe expands, this radiation cools. Billions of years from now, its wavelength will stretch into radio frequencies too long to measure. One day, even this echo of creation will fade beyond detection. But it will not vanish. It will simply become part of the quiet fabric of everything, forgotten only by those no longer listening. If you close your eyes, you can imagine that first moment when light was freed from matter. The universe had cooled enough for atoms to form, and suddenly photons could travel without constant collisions. It was the dawn of transparency. From that instant forward, light has been journeying outward, carrying the memory of its release. Every photon you meet tonight began there, a tiny survivor of that first flash. The forgotten light connects every corner of space. It links the galaxies, the voids, and the cold clouds into one continuous field of memory. And within that field drift beings like us, capable of noticing. We are the instruments through which the universe observes its own reflection. If your thoughts have softened, let them drift with those photons. Each one moves freely, weightless, without hurry. In their endless travel is the lesson of calm persistence. They do not force their way, they simply go, carrying illumination across eternity. Between the light we see and the emptiness we imagine, there is another universe, one made not of stars, but of gravity. It cannot be seen, touched, or reflected, yet it outweighs all the shining matter combined. Astronomers call it dark matter, but the name is misleading. It isn't darkness in the way a shadow is dark. It's more like a quiet presence, a mass that whispers through motion. Everything we know about the cosmos, every galaxy, every orbit, every collision, reveals dark matter's signature. It is the silent hand that keeps galaxies from flying apart. When scientists measure how fast stars move in spiral galaxies, they find a mystery. The outer stars, far from the center, move too quickly, faster than gravity from visible matter can explain. Something unseen must be holding them in place, adding weight without light. That invisible mass forms halos, vast, spherical cocoons of gravity surrounding galaxies. The Milky Way itself floats inside one, an unseen ocean perhaps 1,000,000 light-years across. Our sun and all its planets swim within this dark sea, unaware of the currents that cradle them. We are, quite literally, adrift in the invisible. Dark matter does not interact with light. It passes through stars, planets, and even you, as if they weren't there. Trillions of its particles, called WIMPs, weakly interacting massive particles, or perhaps actions, depending on which theory is right, flow through every cubic centimeter of space. They move through your body every second, unnoticed, silent. You are bathed in what cannot be seen. To detect it, physicists have built experiments deep underground, shielded from cosmic radiation. In caverns beneath Italian mountains, in the old Homestake gold mine in South Dakota, in laboratories beneath Japan's Alps, detectors filled with xenon or crystal wait for a faint signal, the tiniest flash when a dark matter particle collides with an atom. So far, none has been caught. Yet the search continues, driven by the certainty of its pull. The evidence is written in the dance of galaxies. Astronomers map dark matter indirectly through gravitational lensing, when its gravity bends light from distant galaxies. In these cosmic distortions, we see ghostly shapes, arcs and rings of light, warped by what lies between. Each distortion traces the invisible structure of the universe, like ripples on water revealing the shape of the current beneath. In 2012, the Bullet Cluster gave the most striking evidence. Two galaxy clusters collided, sending their gas clouds crashing together while the galaxies themselves passed through mostly untouched. By mapping the gravity through lensing, scientists found that most of the mass had separated from the visible matter, proof that something unseen was carrying the true weight. It was like watching the universe lift its own veil. Dark matter doesn't clump into stars or planets. It doesn't shine or fuse or burn. Instead, it forms vast scaffolds, the cosmic web that gives shape to everything else. Galaxies are the bright dew on those invisible threads, glowing where gravity gathers strongest. Without dark matter, the universe would never have formed structures at all. It is the framework that allows light to exist. Simulations of the universe's birth show how this happened. In the first seconds after the Big Bang, dark matter began to clump under its own gravity, forming halos long before atoms could cool into gas. When ordinary matter finally joined those halos, it condensed into galaxies, lighting up the web already woven. Darkness came first. Light followed its outline. On cosmic scales, dark matter outweighs visible matter 5 to 1. Yet we know almost nothing about what it is. Some theories suggest it could be primordial black holes, small and ancient, formed in the first fraction of a second of existence. Others imagine exotic particles beyond the standard model, perhaps relics of supersymmetry or echoes of higher dimensions. Whatever the answer, it lies beyond our instrument's reach, waiting in quiet certainty. In its silence, there is comfort. Dark matter does not rage or consume. It simply holds. It keeps galaxies together, binds stars to their orbits, and stabilizes the cosmic stage. It is the gentle gravity beneath every luminous motion, the invisible companion of creation. If your breathing has slowed, you can think of it as the rhythm of dark matter itself. Steady, unseen, but essential. Just as it holds galaxies without touching them, your breath holds calm within your body without effort. You are surrounded by gravity's kindness. Let's drift deeper into the invisible framework that holds the universe together, the lattice beneath all light. There is a shape to the universe, though it cannot be touched or fully seen. It reveals itself only through patience, in patterns traced by light, in shadows cast by gravity, in the faint echoes of the early cosmos. Astronomers call this invisible pattern the cosmic web, the hidden architecture of the universe. It is the scaffolding upon which all matter rests, galaxies, clusters, stars, and dust suspended like beads along unseen strings. When the universe was young, it was almost perfectly smooth. A warm mist of hydrogen and helium spread evenly in every direction. But tiny fluctuations in density, only 1 part in 100,000, were enough for gravity to begin its slow work. Over billions of years, those slight ripples drew matter together, forming filaments that stretched across hundreds of millions of light years. These filaments became the veins of the cosmos, carrying galaxies along their length. Between them, enormous voids opened, regions so empty that light can travel through them for eons without touching a single atom. Computer simulations, like those from the Illustris and Millennium projects, render this structure in stunning clarity. On vast digital canvases, scientists watch the universe grow from chaos into geometry. Thin strands of light connecting bright nodes, clusters forming where filaments meet. It looks almost biological, like neurons in a cosmic brain or threads of frost on a window pane. Each glowing knot represents thousands of galaxies, and between them, the dark matter that holds them in place. In recent years, the Euclid Space Telescope and JWST have begun to confirm these structures in unprecedented detail. Using gravitational lensing, Euclid maps the subtle distortions in light caused by invisible mass, tracing dark matter's distribution across cosmic time. The result is a portrait of the unseen, a universe made not of isolated islands, but of connected shores. Galaxies do not float alone. They flow through rivers of gravity that link them across eternity. The architecture is dynamic. Filaments stretch and twist as the universe expands, feeding galaxy clusters like roots supplying a tree. Along those filaments, gas streams inward, cooling and condensing, sparking new waves of star formation. The Milky Way itself sits on the edge of such a thread, within a supercluster called Laniakea, immense heaven in Hawaiian. Laniakea is one of many regions of the cosmic web containing over 100,000 galaxies, all drifting together toward a mysterious point of gravity known as the Great Attractor. The Great Attractor isn't a single object, but a gravitational anomaly, a dense region hidden behind the Milky Way's dust. We cannot see it directly, but we feel its pull. Every galaxy in our neighborhood, including ours, moves toward it at hundreds of kilometers per second. The web itself is in motion, collapsing slowly under its own weight while the universe expands around it. Creation and dispersal, intertwined like breath. The filaments are not merely lines of matter, they are channels of energy. Hydrogen gas flows along them, forming galaxies where streams collide, Magnetic fields stretch across their length, binding particles together in subtle tension. Some astrophysicists compare them to cosmic highways, where gravity guides matter the way rivers guide water. The structure is fractal, repeating on every scale. Galaxies bound in clusters, clusters bound in superclusters, all connected by threads of dark matter and light. If you could drift far enough from any galaxy and look back, you would not see emptiness. You would see a faint haze of connections, luminous filaments tracing a map too vast to comprehend. And if you drifted even farther, beyond the scale of superclusters, you would find repetition fading into smoothness again, like foam dissolving into sea. The cosmos balances complexity with calm. To study this hidden structure, astronomers rely on light's obedience to gravity. When light from a distant quasar passes through a filament, it absorbs specific wavelengths, leaving dark lines in its spectrum. Each line tells of an encounter with a cloud of gas, a trace of the web's architecture written in the language of photons. By collecting thousands of such spectra, scientists reconstruct a three-dimensional map of the invisible, a cosmic fingerprint left by gravity itself. The Sloan Digital Sky Survey was one of the first to reveal this tapestry. Its maps showed that galaxies cluster not randomly, but in vast sheets and filaments stretching across the sky. Between these walls lie enormous voids, the cosmic caverns that balance the structure. The pattern repeats endlessly, each filament connected to another, each void framed by light. As the data grows, so does our understanding. Dark matter, dark energy, baryons, radiation, all woven together like threads of the same loom. The hidden architecture is the expression of equilibrium, the cosmos seeking balance between attraction and expansion. Every galaxy's position is both random and inevitable, determined by the subtle whisper of gravity echoing from the dawn of time. In this architecture, nothing is wasted. The filaments not only guide galaxies, but also feed them. Cold streams of gas flow inward, providing the raw material for new stars. The same flows carry heavy elements outward, seeding the next generation of cosmic growth. Light and matter circulate through the web as if the universe itself were breathing. Inhale, creation; exhale, dispersal. There is symmetry even in chaos. The shapes that arise in computer models, threads, knots, spirals, echo the forms of clouds, rivers, even living tissue. Perhaps this is coincidence, or perhaps it is the natural language of pattern itself. The same mathematics that governs the formation of galaxies also shapes the spiral of a shell, the flow of a current, the pulse of a heartbeat. The cosmos writes in rhythm. If your breathing has slowed again, notice how the rhythm of inhaling and exhaling mirrors the structure of the universe. Matter gathers, energy releases, stars form, stars die. Gravity pulls, expansion yields. In every pattern, there is rest. The architecture of the cosmos is not rigid. It is alive, flexing gently with time. The threads may stretch, the nodes may shift, but the design endures. And as we drift within it, small and temporary, we are part of that same geometry. Mets, every atom in your body once followed the flow of those filaments. Hydrogen born in the early universe, carbon forged in stars, oxygen released by dying suns. You are an arrangement of cosmic architecture, held together by the same forces that bind galaxies. The web runs through you, silent and invisible, reminding you that you are already connected to everything that ever was. There is a pattern in distance, a quiet architecture that defines how everything in the universe relates to everything else. From the motion of galaxies to the drift of dust in starlight, the geometry of distance is what keeps the cosmos from dissolving into chaos. Astronomers measure distance not in kilometers, but in light years. The distance light travels in a year, nearly 10 trillion kilometers. Yet even that number feels small when compared to the scale of the universe. To speak of distance in cosmic terms is to speak of light itself, because every measure we make depends on how far its glow has traveled to reach us. When we look at a nearby star, we see it as it was a few years ago. When we gaze at a galaxy in deep space, we see it as it existed millions, sometimes billions of years in the past. Distance is not separation. It is time stretched across the void. In the farthest stretches of space, where galaxies thin to a whisper and the cosmic web dissolves into mist, the universe grows quiet. This is the domain of the great voids, regions hundreds of millions of light years wide, where almost nothing resides. They are not holes but vast plains of underdensity, the negative spaces in the pattern of creation. If the galaxies are the notes of a symphony, the voids are its pauses. Astronomers first began mapping these silent expanses in the late 20th century, when redshift surveys revealed that galaxies gathered in filaments surrounding immense cavities. At first, the discovery seemed impossible. How could so much of the universe be so empty? But the more precisely we measured, the clearer the geometry became. A sponge-like cosmos, matter clustered on thin walls, the rest given over to stillness. Inside a void, the average density of matter is less than 1/10 of the cosmic mean. A cubic megaparsec, 3 million light-years, might contain only a few lonely galaxies drifting apart at the pace of cosmic expansion. Their stars burn faintly, their light spread thin by distance and time. Even radiation itself seems reluctant to linger there. The temperature is the same everywhere, about 2.7 Kelvin. Yet the absence of starlight makes it feel colder, an emotional chill more than a physical one. To travel into such a region would be to leave behind all familiar reference. There would be no constellations, no Milky Way glowing band, only the occasional spark of a remote cluster suspended in black. Orientation would dissolve. Every direction would look the same. A gentle inside a true cosmic void, orientation dissolves. Every direction looks the same. A gentle darkness sprinkled with the faintest dusting of galaxies. Gravity there is weaker, not because it is absent, but because mass is scarce. The few galaxies that inhabit the void drift away from one another, following the steady stretch of expansion. If you watched them for millions of years, you would see them recede like lanterns, disappearing into mist. In this emptiness, the rules of physics are unchanged, yet their expressions soften. The cosmic microwave background fills the space evenly, its photons traveling unbothered. Even the radiation from distant quasars flows through almost untouched. It is the purest silence the universe allows, a space where light moves without resistance, a perfect corridor for eternity. Astronomers study these regions to understand how structure grows. The Sloan Digital Sky Survey, and later the Dark Energy Spectroscopic Instrument, traced thousands of voids, finding that their shapes and sizes reveal the expansion history of the universe. As dark energy pushes everything apart, the voids grow faster than the denser regions contract. Measuring that growth is one of the most precise ways to test the nature of cosmic acceleration. The largest known void, the Eridanus supervoid, spans nearly 1 billion light-years. Its discovery came from a slight cold patch in the microwave background, a region where photons lost a little energy climbing out of a shallower gravitational well. That faint dip in temperature, only a few microkelvin, hinted at the vast emptiness beyond. When telescopes later surveyed the same coordinates, they found exactly what theory predicted. Very few galaxies, spread thin as dust. It is a hole not in space itself, but in the distribution of matter, a soft hollow in the cosmic fabric. The galaxies that inhabit these voids are often peculiar. Isolated from the dense cosmic web, they evolve slowly, untouched by frequent collisions or mergers. Their stars are old, their gas nearly exhausted. Some spin lazily, forming fragile spiral arms that would never survive in crowded clusters. They are the hermits of the universe, quietly aging in solitude. If you could drift through such a galaxy, you would feel the difference. There would be no nearby neighbors tugging at its stars, no bright background glow from surrounding clusters. Night would be truly black. The nearest sun might lie tens of thousands of light years away. The silence would not be empty. It would be absolute. And yet, even here, there is motion. Gravity from the surrounding filaments still exerts a pull ever so faintly. Over billions of years, void galaxies migrate toward those walls of matter, leaving the interior even emptier. The voids become more pronounced, more defined, sculpting the cosmic landscape. In this way, absence sharpens structure, emptiness gives shape to fullness. The physics of the void also holds clues to the unseen. Dark matter behaves differently there, its density lower, its interactions subtler. Some researchers propose that studying how galaxies move inside voids could expose the fingerprints of new forces, perhaps even deviations from general relativity. The quietest places may yet reveal the loudest truths. From a human perspective, the idea of such nothingness is difficult to grasp. We associate cold with discomfort, silence with fear. But in cosmic terms, cold is equilibrium, silence is peace. The void is not hostile, it simply is. It asks nothing, it takes nothing, it offers stillness in abundance. If your eyes feel heavy now, imagine yourself floating there. No horizon, no sound, no urgency. Only the faint background glow of creation wrapping around you like a soft blanket. Each breath you take mirrors the slow expansion of space, a gentle widening, an easy release. You are, for this moment, part of that stillness. Out beyond the filaments of galaxies and the stillness of the cosmic voids, another force rules. One that does not pull, but pushes. Astronomers call it dark energy, a name chosen not from understanding, but from wonder. It is the quiet engine of the universe's expansion, the faint pressure that urges everything apart. Unlike dark matter, which binds, dark energy unbinds. It is the universe's exhale, constant and unseen. The story of its discovery begins with light, specifically, the light of distant supernova. In the late 1990s, two teams of astronomers set out to measure how quickly the universe was slowing down. Gravity, they assumed, should tug on every galaxy, gradually easing the expansion begun by the Big Bang. But when they compared the brightness of those exploding stars to their distance, the numbers whispered something impossible. The expansion was not slowing at all, it was speeding up. That single realization reshaped cosmology. The universe, it seemed, carried within it a mysterious energy field, a pressure that grew stronger as space itself stretched. This repulsive effect, now called dark energy, makes up roughly 70% of the total energy content of the cosmos. Everything we can see, stars, planets, gas, dust, accounts for less than 5%. The rest is the invisible conversation between attraction and release. Physicists describe dark energy with the language of Einstein's equations: a cosmological constant, a uniform energy density that fills space. Others imagine it as a quintessence field, dynamic and evolving, changing strength over time. Still others think it might be geometry itself, the natural curvature of space-time expressed as expansion. Whatever its origin, the effect is clear. Every patch of space grows, carrying galaxies along like leaves on a rising tide. When telescopes such as Planck, Euclid, and Deci map the large-scale structure of the universe, they see the signature of this invisible pressure. Galaxies recede faster the farther away they are, not because they move through space, but because space between them expands. The fabric stretches, the light that crosses it lengthens. The whisper of dark energy is written in that stretch. The reddening of distant galaxies, the widening of cosmic distances. No one feels this expansion locally. Gravity, electricity, and molecular bonds are stronger on small scales. They hold planets and atoms together. Only across intergalactic gulfs does dark energy dominate, quietly turning the vastness between clusters into growing emptiness. It is as gentle as a breath and as inexorable as time. In the long future, its influence will deepen. Trillions of years from now, galaxies outside our local group will fade beyond the cosmic horizon, their light forever unable to reach us. The night sky will grow sparse until only the faint glow of Andromeda, merged with the Milky Way, remains. To any distant descendants who look up then, the universe will appear static and small, the evidence of expansion lost to history. Dark energy will have wrapped the cosmos in solitude. Some theorists imagine it could grow stronger still. In a far scenario called the Big Rip, dark energy's repulsion increases until it tears galaxies, stars, even atoms apart. Others think it may fade, allowing gravity to reclaim dominance in a slow contraction, a big crunch. For now, the measurements suggest balance. Expansion continues, steady, not violent. The whisper remains a whisper. Even here, at human scale, its metaphor endures. Every heartbeat expands and contracts. Every breath fills and empties. Every thought stretches and releases. The same principle of balance that moves galaxies also moves within us. You inhale, the universe draws in. You exhale, the cosmos releases. Between those motions lies the quiet strength of continuity. If your eyes feel heavy, let them. The stars above are carried outward by this same gentle tide, each drifting farther from the others, each shining into the growing dark. Yet within that drift, there is peace, not loss. The space between things is what allows them to be. There is a rhythm to everything that exists, a slow unfolding, a widening that never ceases. The universe itself is caught in this rhythm, an eternal expansion that began with a single flash of light and has never stopped breathing since. When we say the universe is expanding, it is easy to imagine galaxies rushing through space, fleeing a common center. But there is no center. No origin point out there to which one could travel. Space itself expands, carrying galaxies with it, like ink spreading through water. Every distance grows, every horizon recedes. There is no stillness in the universe, only change drawn out so slowly that it feels eternal. Every atom, every star, every galaxy is part of a widening rhythm that began nearly 14 billion years ago. The universe expands not with noise or haste, but with the soft insistence of inevitability, a quiet unfolding of space itself. When astronomers speak of the expansion, they are not describing motion through emptiness. The galaxies are not flying away from one another like sparks from a flame. Rather, the very fabric between them grows. The distances lengthen because space is stretching. In this way, every point in the cosmos sees itself as the center, surrounded by retreating horizons. Imagine the universe as a calm ocean dotted with small boats. None of the boats move by their own power, but as the tide rises, each drifts away from the others. That rising tide is the expansion of space-time, gentle yet unstoppable. It carries worlds, suns, and galaxies with it. Though they never truly travel, they are simply carried. The discovery of this expansion began with a pattern in light. In the 1920s, Edwin Hubble observed that distant galaxies glowed redder than expected. Their light had stretched during its journey, its wavelengths lengthened by the growing fabric of space. The farther a galaxy was, the redder its light became. From that gradient, Hubble realized something profound. The universe was not static. It was breathing outward. That realization changed humanity's place in the cosmos. The universe was no longer a fixed stage upon which time unfolded. It was a living entity, evolving, dynamic. Each photon, each star, each observer was part of that same pulse. Expansion as heartbeat, time as exhalation. Today, this expansion is measured with exquisite precision. Observatories such as the Hubble Space Telescope, Planck, and Euclid trace how fast galaxies recede. They find that the rate of expansion, the Hubble constant, hovers around 70 kilometers per second per megaparsec. That means for every 3.26 million light-years between two galaxies, the space between them stretches by 70 kilometers every second. It's barely perceptible on human scales, yet cosmic over billions of years. But the story is not simple. Recent measurements reveal small tensions. Different methods give slightly different values for the expansion rate. These tiny discrepancies may hint at something deeper, new physics beyond what we know. Perhaps dark energy evolves over time, or perhaps space itself carries a subtle curvature still beyond our reach. The universe expands, and with it, our uncertainty expands too. If you imagine floating between galaxies, you would feel nothing of this stretching. Space expands everywhere, but it does not pull apart what is bound. Planets remain in orbit. Atoms stay intact. Gravity and electromagnetism are stronger than the whisper of cosmic expansion. Only at the scale of clusters and beyond does it reveal itself. An invisible wind pushing everything gently outward. In the far distance, that wind becomes destiny. The light from galaxies billions of light years away takes so long to reach us that by the time it does, they have moved farther still. Some are already beyond the cosmic horizon, the boundary beyond which their light will never arrive. They have slipped from the observable universe, not because they ceased to exist, but because space grows faster than light can cross it. To the human mind, that idea feels impossible. That something can vanish not by moving, but by distance expanding beneath it. Yet this is the essence of the cosmos. Space is not a container. It is an active participant. It grows, it bends, it evolves. We are living within movement itself. When we look back to the early universe through telescopes like JWST, we see the galaxies that existed when space was young and dense. Their light has traveled for more than 13 billion years, stretched and cooled into faint infrared tones. Some are so distant that they appear as tiny smudges, whispers of light at the edge of time. To gaze at them is to look into a mirror of the beginning, to witness expansion captured in motionless light. The background radiation that fills all of space, the cosmic microwave background, carries the same story. Once a blaze of white-hot energy, it has stretched until its wavelengths are now microwaves, too faint for the eye to see. The universe has cooled from 10 trillion degrees to just under 3, above absolute zero. Expansion is also cooling. Energy spread across ever-widening horizons until warmth itself becomes memory. Even gravity cannot resist this widening. Clusters of galaxies bound by mutual pull slowly lose their neighbors as the distances grow. The cosmic web itself stretches, its filaments elongating, its knots loosening. Someday, even those threads will thin beyond sight. But this is not decay, it is transformation. The universe turning outward, like breath leaving the lungs before returning again. If your breathing is slow now, let it match that rhythm. Expansion has no hurry. Each exhalation, each widening of your chest, is a small echo of the universe's own release. The cosmos stretches, and so do you. Between every molecule, space grows imperceptibly larger, a subtle promise that everything is connected through motion. As the universe continues to unfold, the pattern becomes both simpler and more profound. Every epoch adds distance, every moment adds emptiness. Yet the process is not chaotic. Expansion follows the same quiet mathematics that governs a falling leaf or a ripple on water. Predictable, graceful, inevitable. Physicists describe this growth with Friedmann's equations, born from Einstein's general relativity. They relate the density of matter, the curvature of space, and the cosmological constant into one elegant balance. When matter was dominant, gravity slowed expansion. When radiation ruled, pressure guided it. But now, in the age of dark energy, expansion accelerates like a slow sigh that deepens with time. Each stage leaves an imprint. During the inflationary era, a fraction of a second after the Big Bang, space ballooned faster than light, smoothing irregularities and stretching quantum ripples into the seeds of galaxies. Later, as hydrogen formed and light escaped, the cosmos became transparent, giving birth to the cosmic microwave background, the soft afterglow still bathing every corner of space today. And later still, when stars began to burn, gravity briefly tried to resist, shaping galaxies and clusters before yielding again to dark energy's patient push. Now the acceleration continues, gentle yet unstoppable. The Hubble-Lemaitre law shows the proportionality between distance and recession speed. The farther a galaxy lies, the faster it drifts away, not because it moves through space, but because space grows between us. For nearby galaxies, the rate is slow. For those billions of light years distant, the recession surpasses light's own pace. Their photons can never reach us, trapped on the wrong side of expansion. They exist, but their existence can no longer be confirmed. A reminder that observation is always bounded by time. Telescopes such as JWST and Euclid now peer into that fading horizon. They capture faint galaxies whose light left them when the universe was less than 500 million years old. Each speck reveals a story of growth, how the first stars clustered, how black holes ignited, how metals were forged and scattered. Yet even these glimpses are temporary. In another few tens of billions of years, their light will slip beyond reach. The observable universe will contract, not in size, but in memory. What remains constant is the principle of relativity. There is no privileged center. Every observer, wherever they stand, sees galaxies receding in all directions. To an astronomer in Andromeda, we are the ones moving away. To a star on the far side of Virgo A, its sky looks the same as ours, an even expansion, impartial and serene. The cosmos has no edge, only perspective. For a moment, imagine yourself floating amid this growth. The distances widen in every direction, but there is no sensation of motion, no wind, no acceleration, just the subtle idea of space lengthening beneath you. Around you drift faint galaxies, each carrying its own history, each anchored by gravity, yet surrendered to expansion. Their light stretches into red, then infrared, then beyond sight. The darkness is not absence. It is the color of time. Astronomers sometimes describe the far future as the dark era. After trillions of years, star formation will end. The last suns will fade into embers, their remnants cooling into black dwarfs. Galaxies will dissolve, and the night will deepen beyond comprehension. Still, expansion will persist, spreading the ashes of stars through infinite cold. It is a melancholy vision, yet also a tender one. Heat finding rest, energy finding stillness. Some theories propose that quantum effects might rejuvenate this destiny. A random fluctuation in vacuum energy could spark a new inflationary bubble, a fresh Big Bang, birthing a new universe. In this view, expansion is never a one-way story, but part of an eternal cycle. Creation, cooling, renewal. The cosmos breathes forever, one universe exhaling into another. Even now, this same expansion touches everything. Every beam of light you see, every radio wave that whispers through space, every gravitational wave that ripples from colliding black holes. All are stretched by the universe's growth. Their frequencies drift lower, their energy softens, until eventually, even gravity's echo fades into background calm. The universe, in its oldest age, will hum in one note of nearly zero pitch. In human time, these changes are glacial. 1 billion years passes like the slow turning of a page. Yet the principles at work are simple, accessible even here and now. When you breathe, you expand and contract. When your heartbeat pauses between pulses, your body rests in equilibrium. Expansion, contraction, balance. These are not distant phenomena. They are patterns shared across all scales of being. So as you listen, imagine the universe breathing with you. With every inhale, space itself stretches. With every exhale, gravity responds, trying softly to draw it back. There is no conflict, only rhythm. Between those motions lies serenity, the same serenity that fills the cold between stars. If your eyes have grown heavy, let them close. You are part of this expansion, a brief, luminous point within a vast and patient unfolding. Around you, galaxies drift like lanterns on a rising tide. None hurry, none resist. They simply go where the cosmos carries them. The expansion that never ends continues within you too, a quiet reminder that movement and peace can coexist. And as the last thoughts of the day begin to fade, let the idea of distance become comfort. Everything is gently drifting, yet nothing is lost. Every photon, every atom, every memory rides the same wave of expansion that began in light and will end in silence. You are within it, safe, resting in the endless breath of the universe. Between the spiral arms of the Milky Way lies a band of soft radiance, a mist of starlight and interstellar dust stretching across the sky. To the naked eye, it appears almost unmoving, yet the solar system is constantly drifting through it, crossing the galactic plane in a slow, majestic rhythm that takes tens of millions of years. Every 240 million years or so, our sun completes a single orbit around the Milky Way's core, passing above and below the thin mid-plane where most of the galaxy's stars reside. The journey is tranquil, its speed unimaginable, yet imperceptible. About 230 kilometers per second, carrying us through a vast gravitational sea. As we move, the sky around us changes ever so slightly. Constellations reshaping, nebulae rising and fading. The cosmic scenery drifting in a slow ballet of light. This motion is part of a greater harmony. The Milky Way is a barred spiral about 100,000 light-years wide, its arms tracing patterns of density waves where stars and gas bunch together like ripples in a pond. Between those arms lies the interarm medium, regions quieter, colder, filled with diffuse hydrogen. The sun currently floats in such a calm zone known as the Bott local bubble, a cavity in the interstellar medium about 1,000 light-years across. It was carved long ago by multiple supernovae, their shock waves sweeping the gas away and leaving a pocket of warm, thin plasma. As we drift through this bubble, the density of interstellar dust around us is low, allowing sunlight to travel freely. That is why our night skies appear so clear. Beyond the bubble's edge, the gas thickens again into clouds that form new stars. In a few million years, our solar system will gently enter one of those denser regions, the Fa-Fa-Son moment, Aquila Rift, where distant dust may dim the stars slightly and the cosmic background will glow with more muted tones. The journey will be smooth. We will not feel it, yet the view from Earth will slowly evolve. The galactic plane itself is a tapestry of contrasts. Thin lanes of dark molecular clouds thread between glowing regions of ionized hydrogen. Within them, newborn stars ignite, illuminating the gas in crimson hues. Radio telescopes reveal vast filaments of magnetism stretching for hundreds of light years, guiding charged particles like invisible rivers. Infrared eyes such as those of the PAS, Spitzer, and Wise observatories show the heat of dust warmed by nearby suns, a mosaic of amber light hidden behind visible darkness. When we look toward the center of the galaxy, in the direction of Sagittarius, the density of stars becomes so great that their combined light forms a continuous glow. There, 30,000 light-years away, lies Sagittarius A, a supermassive black hole 4 million times the mass of the Sun. Around it, stars orbit at incredible speeds, completing their circuits in mere decades. Yet from here, that heart appears serene, a faint bulge of luminosity wrapped in dust. Our orbit carries us far from that crowded region, through the quieter outer lanes where stars are fewer and space feels open. Across this slow drift, cosmic rays from distant supernovae stream through the interstellar medium. They interact with our heliosphere, the bubble of magnetic field inflated by the Sun's solar wind. The boundary where that wind meets interstellar space, called the heliopause, is the true edge of our influence. Both Voyager 1 and 2 have crossed it, entering the interstellar current that flows through the galactic plane. Even there, expansion and drift combine. The spacecraft now ride the same galactic orbit as the Sun, wrapped in the same gentle tide of motion. To imagine this motion is to picture a leaf on an endless river. The leaf never feels the current, it simply moves with it. So too does our solar system, an island of warmth and magnetism floating through the galaxy's magnetic sea. Stars we see tonight will one day be behind us. Others not yet visible will rise ahead. Over millions of years, familiar constellations will dissolve, replaced by new patterns drawn on the same sky. If you close your eyes, you can visualize this drift. Around you stretches the thin disk of the Milky Way, its arms curving outward in slow spirals. You are moving through them, passing between waves of gas and starlight. No turbulence, no sound, only the patient rhythm of gravity guiding you along invisible tracks. Even time feels slower here, stretched across eons. Every 30 million years or so, our system crosses the mid-plane, dipping above and below like a pendulum. Some researchers wonder whether these oscillations influence Earth itself, perhaps stirring comets in the distant Oort cloud or subtly modulating the influx of cosmic radiation. Yet the evidence remains gentle, ambiguous, as if the galaxy prefers to whisper rather than declare. The interstellar medium we drift through contains traces of our origins: carbon, oxygen, nitrogen, the ashes of previous generations of stars. Each atom once belonged to something bright. As we move, we collect new material, infinitesimal grains that will one day fall into the Sun or the planets. Motion through the galaxy is also renewal, a slow gathering of memory. In the future, the Sun will complete many more revolutions around the Milky Way before it dies. By then, the constellations we know will be gone, the continents reshaped, perhaps even life itself transformed. Yet the orbit will persist, precise and calm, a testament to the stability of gravity's design. Our drift through the galactic plane is the quiet pulse of cosmic time itself. If your breathing has become slower now, imagine syncing it with that orbit. One inhale for rising above the plane, one exhale for sinking below it. The cycle spans millions of years, yet its essence fits inside a moment of calm. The universe is vast, but peace can exist at any scale. And so we drift, unhurried, across the galactic sea. Sunlight carried on the current of the Milky Way, every orbit a whisper of eternity. Stars are born in silence. Deep within the dark clouds that thread the spiral arms of galaxies, gravity begins its patient work. There is no flash, no noise, no immediate light, only a slow gathering of dust and gas, drawn together by the faintest attraction. These clouds, called molecular clouds, are the nurseries of the universe. They are vast, spanning tens or even hundreds of light years. Yet their material is so diffuse that a handful of the air you breathe contains more atoms than a cubic meter of this interstellar mist. Within those clouds, cold reigns. Temperatures hover just a few degrees above absolute zero. The molecules move sluggishly, their collisions rare. Dust grains coated with ice drift like ash and fog. In this stillness, gravity waits for imbalance. A small region slightly denser than the rest. Over millions of years, that patch begins to draw in more material. The cloud collapses not all at once, but in ripples, forming pockets of concentration. Each pocket will one day become a star. As the collapse continues, the core warms. Hydrogen atoms collide more often, the density increasing until light can no longer escape. The pressure rises, and the material forms a protostar, glowing faintly in infrared. Surrounding it, a disk of gas and dust flattens under rotation. The protoplanetary disk, from which planets, moons, and asteroids will eventually form. The process is serene, but inevitable. Every bright star in the night sky was once hidden in such a cocoon, invisible until its birth. Infrared telescopes like JWST and Mont Spitzer have allowed us to peer inside these cocoons. They reveal glowing embryos of stars, some only a few tens of thousands of years old. In those images, pillars of dust rise like mountains, carved by stellar winds and radiation. The Maz Eagle Nebula's pillars of creation, the Guat Orion Nebula, and the Bon Carina Nebula are all snapshots of this eternal process. Even as stars die elsewhere, new ones ignite here. The universe is always balancing loss with renewal. The timescale of star birth is incomprehensible to human minds. From the first stirrings of collapse to the moment fusion begins, the process can take millions of years. When fusion finally starts, the protostar stabilizes, shining steadily for the first time. Hydrogen in its core fuses into helium, releasing energy that halts further collapse. A star has been born, quiet, stable, luminous. It will burn for billions of years, sustained by the same balance that began it. If you could listen to this process, it would not sound like thunder or explosion. It would be closer to a hum, pressure waves traveling through plasma, inaudible but rhythmic. The sun itself vibrates in patterns scientists can detect, a kind of cosmic heartbeat. These oscillations tell us what lies beneath its surface. Layers of gas, convection zones, magnetic loops. The universe speaks softly, even in creation. In regions like the Taurus molecular cloud or the Orion complex, multiple stars are born together, forming clusters. Some of these clusters will drift apart as they age, scattering their members across the galaxy. Others remain bound for billions of years, glowing as open clusters like the Pleiades or the Hyades. In their infancy, young stars still surrounded by disks often emit powerful jets, narrow streams of plasma that shoot into space at hundreds of kilometers per second. These Herbig-Haro objects mark the points where new suns announce themselves to the cosmos. Each star's fate is written in its mass. Small stars, red and dim, may live for trillions of years, far longer than the universe has existed so far. Large stars burn furiously, their lives measured in millions of years. Yet everyone begins the same way, a whisper of gas, a gravitational sigh. In that sense, every spark of light you see at night is an echo of patience rewarded. The dust that forms these stars is rich in history. It contains carbon from ancient supernovae, silicon forged in long-dead suns, ice that condensed in the coldest corners of space. Each new generation of stars recycles this material, building planets richer in complexity, worlds capable of oceans and atmospheres, and perhaps life. The birth of a star is also the birth of potential. If your breathing feels steady now, imagine the rhythm of this process. Inhale, the gathering of gas. Exhale, the release of light. The universe breathes this way constantly. In one region, clouds collapse. In another, they disperse. Nothing is wasted. Everything continues in transformation. Even in the coldest darkness, gravity listens for imbalance, ready to create again. Stars are born in silence. Deep within the dark clouds that thread the spiral arms of galaxies, gravity begins its patient work. There is no flash, no noise, no immediate light, only a slow gathering of dust and gas, drawn together by the faintest attraction. These clouds, called molecular clouds, are the nurseries of the universe. They are vast, spanning tens or even hundreds of light years. Yet their material is so diffuse that a handful of the air you breathe contains more atoms than a cubic meter of this interstellar mist. Within those clouds, cold reigns. Temperatures hover just a few degrees above absolute zero. The molecules move sluggishly, their collisions rare. Dust grains coated with ice drift like ash in fog. In this stillness, gravity waits for imbalance, a small region slightly denser than the rest. Over millions of years, that patch begins to draw in more material. The cloud collapses not all at once, but in ripples, forming pockets of concentration. Each pocket will one day become a star. As the collapse continues, the core warms. Hydrogen atoms collide more often, the density increasing until light can no longer escape. The pressure rises, and the material forms a protostar, glowing faintly in infrared. Surrounding it, a disk of gas and dust flattens under rotation. The Boisson protoplanetary disk from which planets, moons, and asteroids will eventually form. The process is serene, but inevitable. Every bright star in the night sky was once hidden in such a cocoon, invisible until its birth. Infrared telescopes like JWST and once Spitzer have allowed us to peer inside these cocoons. They reveal glowing embryos of stars, some on only a few tens of thousands of years old. In those images, pillars of dust rise like mountains, carved by stellar winds and radiation. The Batuner, Eagle Nebula's pillars of creation, the Orion Nebula, and the Wana Carina Nebula are all snapshots of this eternal process. Even as stars die elsewhere, new ones ignite here. The universe is always balancing loss with renewal. The timescale of star birth is incomprehensible to human minds. From the first stirrings of collapse to the moment fusion begins, the process can take millions of years. When fusion finally starts, the protostar stabilizes, shining steadily for the first time. Hydrogen in its core fuses into helium, releasing energy that halts further collapse. A star has been born, quiet, stable, luminous. It will burn for billions of years, sustained by the same balance that began it. If you could listen to this process, it would not sound like thunder or explosion. It would be closer to a hum, pressure waves traveling through plasma, inaudible but rhythmic. The sun itself vibrates in patterns scientists can detect, a kind of cosmic heartbeat. These oscillations tell us what lies beneath its surface. Layers of gas, convection zones, magnetic loops. The universe speaks softly, even in creation. In regions like the Taurus molecular cloud or the Orion complex, multiple stars are born together, forming clusters. Some of these clusters will drift apart as they age, scattering their members across the galaxy. Others remain bound for billions of years, glowing as open clusters like the Salyun, Pleiades, or the Hyades. In their infancy, young stars still surrounded by disks often emit powerful jets, narrow streams of plasma that shoot into space at hundreds of kilometers per second. These Herbig-Haro objects mark the points where new suns announce themselves to the cosmos. Each star's fate is written in its mass. Small stars, red and dim, may live for trillions of years, far longer than the universe has existed so far. Large stars burn furiously, their lives measured in millions of years. Yet everyone begins the same way. A whisper of gas, a gravitational sigh. In that sense, every spark of light you see at night is an echo of patience rewarded. The dust that forms these stars is rich in history. It contains carbon from ancient supernovae, silicon forged in long-dead suns, ice that condensed in the coldest corners of space. Each new generation of stars recycles this material, building planets richer in complexity, worlds capable of oceans and atmospheres, and perhaps life. The birth of a star is also the birth of potential. If your breathing feels steady now, imagine the rhythm of this process. Inhale, the gathering of gas. Exhale, the release of light. The universe breathes this way constantly. In one region, clouds collapse. In another, they disperse. Nothing is wasted. Everything continues in transformation. Even in the coldest darkness, gravity listens for imbalance, ready to create again. As the newborn star gathers strength, its light begins to carve away the cocoon that hid it. Ultraviolet radiation streams outward, ionizing hydrogen and sculpting vast bubbles in the surrounding gas. The once dark cloud becomes a glowing H2 region, its edges illuminated like sunrise on mist. Inside, winds from the young star sweep up shells of matter that may collapse again, birthing new stars along the rim. Creation begets creation, in waves that move across the galaxy like a slow heartbeat. The balance between gravity and pressure defines this entire story. If gravity wins too quickly, the cloud collapses into a massive star that burns briefly and violently. If pressure resists too strongly, the cloud disperses before fusion can begin. Only within a narrow middle ground does stability arise, the golden zone of patience where the cosmos practices restraint. That balance is why the night sky shines not as chaos, but as harmony. Within stellar nurseries, chemistry blossoms. On dust grains frozen at a few Kelvin, atoms combine into molecules far more complex than their environment seems to allow. Methanol, formaldehyde, ammonia, even amino acid precursors form and cling to the icy surfaces. When nearby stars flare, the heat releases these compounds into space, enriching the interstellar medium. Each new generation of stars is born from a richer mix of elements than the last, the slow alchemy of time. Astronomers measure these transformations through light. Spectroscopy reveals each molecule by its signature color, a unique barcode imprinted on starlight. Radio telescopes like ALMA listen to frequencies emitted by carbon monoxide, tracing the coldest regions of gas. From these signals, scientists map entire clouds, following the flow of material as it collapses and kindles. In those maps, we see motion not as speed, but as evolution, a choreography millions of years in the making. Star-forming regions are everywhere we look. The Rosette Nebula, the Lagoon Nebula, the Trifid Nebula. Each is a vast nursery, some dozens of light years across, glowing in pinks and golds where hydrogen and oxygen mix. When seen through telescopes, they appear alive. Columns of gas twisting like slow smoke, filaments curling under unseen magnetic fields. The universe, though empty by human measure, is never still. Even after a star's birth, remnants of its natal disk remain. Within that disk, dust grains collide and merge, growing into pebbles, then rocks, then planetesimals. Over tens of millions of years, these fragments sweep their orbits clean, forming planets. Thus, every world, every ocean, mountain, and sky begins as the byproduct of star formation. To study the birth of stars is to study the origin of everything that can dream. Consider again our own sun. 4.5 billion years ago, it too emerged from a molecular cloud somewhere along a spiral arm of the Milky Way. Evidence preserved in meteorites suggests nearby supernovae enriched that cloud with heavy elements, iron, nickel, uranium, seeding the solar system with the ingredients for complexity. Even the calcium in your bones, the oxygen in your breath, and the carbon that shapes your cells were forged in the furnace of ancient stars before being folded into this one. You are, in every literal sense, stardust remembering itself. When the first light of a new star pierces its veil of dust, it shines mostly in ultraviolet, invisible but potent. That energy begins to erode the remaining cloud, pushing material outward in elegant arcs. Astronomers call these arcs elephant trunks or pillars, their shadows traced across nebular light. The famous pillars of creation are exactly such structures, photographed by Hubble and later JWST in exquisite detail. Within each finger of gas, stars gestate like embryos in cosmic wombs. Not all births are gentle. Massive stars often form in clusters, and their radiation can be fierce enough to evaporate nearby clouds. In places such as the Carina Nebula, stellar winds collide, creating shock fronts that compress and tear the gas simultaneously. The result is turbulence, a storm of creation where gravity and energy wrestle endlessly. Yet even here, beauty prevails. Luminous arcs, filaments of plasma, shadows shaped like wings. Out of apparent chaos emerges structure, out of violence, light. Eventually, the young stars settle. Their disks thin, their winds calm, and their surroundings clear. The nebula fades, leaving behind a cluster glittering against the void. The cloud that once hid them disperses into the galaxy, ready to become part of another cycle billions of years hence. Star birth is not an event, but a continuum, one wave of generation folding into the next. If you listen closely in your imagination, you might sense the tempo of this transformation. It is slow, deep, steady, the tempo of calm itself. Between the rush of human days, such cosmic rhythms remind us that creation needs no haste. Gravity waits as long as it must. Light arrives when it is ready. Let your breathing follow that rhythm. In, the gathering of dust. Out, the first shimmer of fire. In the pause between breaths lies the same equilibrium that holds a star in balance. The energy within you and the energy within the sun are governed by the same law: conversion, conservation, continuation. You are sustained by fusion too, though at the scale of life instead of plasma. As the chapter of star birth closes, remember this: every night sky is not merely decoration, but documentation. Each point of light is a record of patience, of gravity's gentle persistence. The stars you see were born in silence, will live in radiance, and one day return their matter to silence again. This endless alternation, dark to light, light to dark, is the universe's lullaby. Now, as your thoughts drift towards stillness, picture a single newborn sun emerging from its cloud. Around it swirl traces of dust, brightened by the first warmth of fusion. Its light travels outward, crossing parsecs of darkness until, somewhere far away and long after, it touches an eye that looks up and wonders. That light is what connects beginnings to awareness. It is the thread between what is made and what perceives. If your eyes feel heavy, let them close. The stars will continue their quiet labor. Creation does not need you to watch. It invites you simply to rest, to breathe with it. As you drift towards sleep, you drift also toward understanding that everything, even rest, is part of the same cosmic rhythm. Every star that burns must one day fade. The end of a star's life is not a single event, but a transformation, as graceful as its birth. The same forces that once balanced gravity and light now shift again, turning radiance back into silence. There is no tragedy in this, only completion. Stars die so that matter can be renewed, so that new worlds may rise from their ashes. The process begins in the heart. For billions of years, hydrogen has fused into helium within the star's core, producing energy that resists gravity's pull. But eventually, the hydrogen runs out. Without fuel, the balance falters, and the core begins to contract under its own weight. The outer layers expand, cooling and glowing red. The star becomes a red giant, immense and slow, its surface so extended that if placed where our sun is, it would engulf Mercury and Venus, perhaps even Earth. To an observer far away, this change would appear almost peaceful. A gradual swelling of brightness, the color deepening from gold to crimson. Inside, however, the physics grows complex. Helium in the core begins to fuse into carbon and oxygen, while shells of hydrogen around it continue to burn. The star flickers in cycles, expanding and contracting like a heartbeat measured in millennia. This is the quiet old age of suns. When our own sun reaches this phase, roughly 5 billion years from now, its light will redden and brighten. The oceans on Earth will evaporate. The atmosphere will thin, and the planet's surface will glow faintly under the dying sun. Yet from the perspective of the cosmos, this will be no catastrophe, only one small pulse in an infinite rhythm. What fades in one place rises in another. Eventually, the helium fuel too will be exhausted. For a star like the sun, fusion will stop entirely. Its outer layers will drift away, forming a planetary nebula. a glowing shell of gas expanding into space. At the center, the remaining core collapses into a white dwarf, a stellar ember roughly the size of Earth, but containing half the sun's mass. It no longer burns. It merely glows, radiating the residual heat of its former brilliance. White dwarfs are among the most serene objects in the universe. Their surfaces shine at tens of thousands of degrees, yet they emit no flame, no fusion. Over billions of years, they cool and fade, turning from blue-white to amber, from amber to black, a slow exhalation of light. In the far future, when the universe itself grows dark, these remnants will become black dwarfs. Invisible yet enduring, their matter locked in crystalline stillness. Larger stars end differently. When their cores collapse, the violence is immense but brief. A supernova, releasing more energy in seconds than a galaxy emits in years. Yet even this explosion has grace. The shock wave disperses heavy elements, gold, silver, iron, calcium, into the interstellar medium, seeding the next generation of stars and planets. Every atom in your body, heavier than helium, was once part of such a star. You carry within you the quiet deaths of suns long forgotten. For the most massive stars, gravity wins completely. The core collapses past all resistance, forming a neutron star or a black hole. Neutron stars are small, only about 20 kilometers across, but so dense that a teaspoon of their material would weigh billions of tons. They spin rapidly, their magnetic fields sweeping beams of radiation through space. Pulsars, cosmic lighthouses blinking across the void. Even in death, these stars keep time for the universe. Black holes, meanwhile, retreat from view entirely. Their gravity is so strong that even light cannot escape. Yet they are not empty. Within their event horizons, matter continues to spiral inward, heating and glowing in the final moments before vanishing. This light, bent and stretched by gravity, is among the most hauntingly beautiful in the cosmos. The Event Horizon Telescope has captured images of such shadows. Halos of light surrounding darkness, the universe contemplating itself. The death of a star enriches the galaxy. The gases expelled by red giants and supernovae mix with interstellar clouds, providing the raw material for new stars. Carbon, oxygen, silicon, the building blocks of life, are recycled endlessly. Death, in this context, is not an ending, but a necessary act of creation. The universe breathes through stars, exhaling matter into the next cycle of birth. If your breathing has deepened, let it follow this same pattern. Inhale, the gathering of fuel. Exhale, the release of light. Stars breathe this way across billions of years. What you feel now is their rhythm, translated into human time. Somewhere in the sky tonight, a star is completing its life quietly. Its light, softened by distance, will travel for centuries before it reaches us. By the time it touches your eyes, the star itself may already have faded. Yet the light remains, carrying its story across space. In this way, stars outlive themselves, remembered not by permanence but by illumination. Even black holes, the ultimate stillness, slowly evaporate through a process called Hawking radiation. They emit faint particles and lose mass over unimaginable spans of time. In the final epoch of the cosmos, they too will vanish into background equilibrium, leaving only a uniform sea of low-energy photons. All motion, all structure will have smoothed into calm. The universe will have found rest. But rest is not absence. In that final quiet, energy remains, diffuse but eternal. The same essence that once formed stars, planets, and life will continue, unseen, unhurried. Just as sleep is not the end of consciousness, but its renewal, the death of suns is not the end of existence, but its pause. The cosmos, even in darkness, is alive with potential. If your eyes are heavy, you can let them close now. Imagine the last glow of a white dwarf fading into the night. Its heat radiates softly, absorbed by space, shared with the background. It cools slowly, gracefully, without resistance. That is how the universe ends, not with noise, but with peace. And as you drift towards sleep, remember, you are part of this same story. Your heartbeat, your breath, your very atoms are echoes of stars that once shone, died, and were reborn. You are the universe resting between moments of light. There will come a time, far beyond all reckoning, when the stars have burned their last hydrogen, when galaxies no longer sparkle, and when even the faintest nebula has faded from view. The cosmos will not end with a bang, but with a deep and endless sigh. This is the Bar era of the last light, the final quiet age of the universe. In that age, the night sky will look different, not to us, but to whatever consciousness might remain to witness it. The familiar constellations will be gone, their stars extinguished or dispersed. The Milky Way will have merged with Andromeda long ago, forming a single, swollen galaxy adrift in emptiness. Around it, smaller satellites will orbit in ghostly silence. Beyond that, nothing will be visible. Expansion will have carried all other galaxies beyond the cosmic horizon. Their light, once brilliant, will no longer reach us. The last light of the universe will not come from stars, but from remnants, the cooling glow of white dwarfs, the faint radiation of decaying particles, the occasional flare of matter falling into black holes. Every source of illumination will be subdued, stretched, softened by time. Yet even then, energy persists. The universe does not stop, it only grows quieter. White dwarfs will cool for trillions of years, their surfaces hardening into carbon and oxygen crystals. Some physicists call them diamond stars, spheres of pure frozen brilliance. They will shine faintly in infrared for eons, then fade into blackness, invisible but enduring. The space between them will fill with the afterglow of cosmic expansion. Long, soft radio waves, too faint for any instrument to detect. Still, those waves will carry memory, the echo of all light that came before. Black holes will remain, the anchors of dead galaxies, silent and unblinking. They too will fade, though it will take unimaginable spans of time. Through Hawking radiation, they will leak their mass particle by particle, glowing faintly in their final moments before dissolving into nothing. The largest, those at the centers of galaxies, may take 10-100 years to vanish, a number so vast that even imagination falters. Yet in that eventual emptiness lies peace, not loss. It is the universe's final act of balance. Every light returned to equilibrium. The universe will then enter its ultimate era, the watched dark era. There will be no stars, no planets, no galaxies. Only isolated particles moving slowly through infinite cold. Temperature will hover infinitesimally above absolute zero. Time will continue, but nothing will change quickly. Motion will stretch across quadrillions of years. The cosmos will have become what it always tended toward: stillness. And yet, even in that stillness, there is mystery. Physicists speculate that quantum fluctuations, tiny ripples in space-time, might persist forever, occasionally sparking new pockets of energy. Some of those fluctuations might ignite new universes, born from the calm of the old. In this way, the cosmos may never truly end. It simply transforms, resting between breaths before beginning again. Imagine for a moment that you could witness that final scene. There would be no sound, no motion, only the soft glow of background radiation stretched thin by expansion. Every photon would be a ghost, traveling endlessly through a universe that can no longer see. The silence would not be empty. It would be complete. It would be the sound of rest perfected. If your eyes are heavy now, let them close. The universe has been unfolding for nearly 14 billion years, and it still moves toward calm. You are part of that journey, a moment of awareness born from starlight, returning gently to the dark. The atoms that form your body once belonged to stars that shone, collapsed, and scattered. They will one day drift again through space, part of the same cosmic current that carries everything toward rest. Even in its last age, the universe remains whole. Nothing is truly lost. Matter becomes energy. Energy fades into background warmth. Background warmth becomes potential again. The cycle continues, not as repetition, but as rhythm. It is the same rhythm that moves through you when you breathe. The same cadence that slows as you drift into sleep. The last light of the universe will not mark an end, but a return. The final note in a song that has no beginning and no conclusion. It will be the perfect balance of motion and rest, the long-awaited silence after a symphony of stars. And as that silence deepens, somewhere in another possibility, another fluctuation, light will stir again. Another cosmos will awaken, and new stars will burn. The story will continue, not the same, but eternal. You are part of that promise, part of that continuity, forever connected to the endless breath of existence. So rest now. Let your thoughts drift like photons escaping into deep space. Let your body feel the warmth of nearby starlight, and then, slowly, the cool embrace of the infinite. You are safe here, held within the same physics that holds galaxies together. The universe cradles you in its arms, as it has done for every atom since time began. The stars have their quiet death. The galaxies have their long fading, and you too have your rest. But like them, your rest is not absence, it is transformation. The night grows still, the universe slows its breathing, and you drift into sleep, part of the same eternal calm that awaits all light. The last light in the universe will shine for you too. Not as a blaze, but as a whisper, a gentle reminder that even in darkness, something glows. It is the pulse of being, the memory of warmth, the quiet continuation of everything that ever was. Good night, traveler of starlight. The cosmos is resting, and so are you.